Hello everyone, we are here to discuss the last topic of the number system, rationalization. If denominator is irrational, just as given in the example, then the process of converting its denominator to a rational number, this process was known as rationalization, by multiplying with a suitable rationalizing factor. 3 upon root 3, 3, this root 3, if we multiply root 3 by root 3, then it becomes a rational number. So we have chosen here the rationalizing factor is root 3. 3 root 3 upon root 3 into root 3. This 3 root 3 rational and irrational number. This root 3 becomes 3, cancel out, the answer is root 3. Now the new term is here rationalizing factor. What is this? Rationalizing factor. If the product of two irrational number is rational, then each one is called the rationalizing factor of the other. So let me explain this with an example. Suppose here we are having one rationalizing number. Suppose we are having here cube root of 9, we can take this, and product of cube root of 3 we can take here. So if we multiply these two, because the same surds are here, same roots are here, so we can multiply them, we can write them together in a single bracket, this one. So this is cube root of under root 27. So this can be write as 27 to the power 1 upon 3, and this can be write as 3 to the power 3 into 1 upon 3. This can be cancelled, and this is 3. So we have chosen here 3 irrational numbers, cube root of 9 and cube root of 3, and if we multiply them, it is given here if the product of two irrational number is rational. So we are in this example, we are having the product of two irrational number is rational, then they are the rationalizing factor of each other. Cube root of 9 is a rationalizing factor of cube root of 3, and cube root of 3 is a rationalizing factor of cube root of 9. This is given here. Now the next thing is there, if a to the power 1 upon n, this we are having in the form of 1 upon n, is a monomial irrational number, then rationalizing factor is in the form of a to the power minus 1 upon n. Here we are having 1 upon n, that's why we have taken here 1 upon n. Just example, you can see fifth root of 4. So we can write as 4 to the power 1 upon 5. 4 can be simplified, 2 to the power 2. 1 upon 5, so it becomes 2 to the power 2 upon 5. Instead of 1 upon n, we are having here 2 upon n, just like it is 1 upon n, but on simplification we are having here 2 upon 5. So our rationalizing factor of 5th root of 4 becomes 2 to the power 1 minus 2 upon 5, not 1 upon 5 becomes here, because on simplification we are having a power 2, not 1. So that's why 1 minus 2 upon 5. So 2 to the power LCM, 2 to the power becomes 3 upon 5. So 2 to the power 3 upon 5 is the rationalizing factor of 2 to the power 2 upon 5. Or we can write it like 2 to the power 3 of 5th root is the rationalizing factor of 5th root of 4, like this. Similarly, we can take this examples also root 8. Root 8 can be written in the form of, first we will simplify, then only we can find the rationalizing factor. So root 8 is 2 into 2 into 2. So you know that this is in pair, so it can be come out from the root. So 2 root 2. So this is 2 multiplied 2 to the power 1 upon 2. Now we will find the rationalizing factor of only 2 to the power 1 upon 2, not of 2. So that's why the simplification of the given number is necessary. So 2 to the power 1 upon 2. So we know that in the formula that a to the power 1 upon n. So we are having a to the power minus 1 upon n. So it becomes 2 to the power half, 2 to the power 1 minus 1 upon 2, so again 2 to the power half. Similarly, the example I have given here, this one, this I have given, so we can verify with this formula also. So this is here cube root of 9, so we can write it like 9 to the power 1 upon 3, or we can write 3 to the power square to the power 1 upon 3, so we can write it like 3 to the power 2 upon 3. So what is the rationalizing factor is equals to 3 to the power 1 minus 2 upon 3. So this becomes 3 to the power 1 upon 3. So or we can write it like cube root of 3. So that was the another number that I've told in the product, but we can verify this with the formula of a to the power minus 1 upon n. Similarly, if we check this we are having cube root of 3. So we can write it 3 to the power 1 upon 3. So rationalizing factor with this formula 3 to the power 1 minus 1 upon 3. It becomes 3 to the power 2 upon 3, or we can write 3 to the power 2 whole cube, or we can write 3 square is 9. So this is cube root of 9. So this was the second number. So rationalizing factor of 3 root 3 is cube root of 9, and the rationalizing factor of cube root of 9 is what? Cube root of 3. So this we have verified. Also similarly, one more example, to multiply fifth root of 4 upon fifth root of 16. So we can write it like 2 into 4 to the power 1 upon 5, 16 to the power 1 upon 5. As I told you earlier that we have to simplify this. 2 to the power 2, 4 becomes 2 to the power 2, 16 becomes 2 to the power 4. So this will be 2 to the power 2 upon 5, 4 upon 5. Now with the help of exponents law, when divide, we'll subtract the power. So we are having minus 2 upon 5. So here is minus 2 upon 5. But the formula is already a 1 minus 1 upon n. So we will not do like this a to the power minus 1 upon n. Otherwise, because of this sign, this becomes minus. So simply we take the rationalizing factor of 2 to the power minus 2 upon 5 as 2 to the power 2 upon 5. Positive. Now the next examples are there. What type of question you will get? So this is the rationalizing factor 3 plus 2 root 2. The rationalizing factor of 3 plus root 2 becomes 3 minus root 2, because you are familiar with the identity a plus b and a minus b. It becomes a square minus b square. So because of the squares, the root will cancel out. So rationalizing factor of 3 plus root 2 becomes 3 minus root 2, and rationalizing factor of 3 minus root 2 becomes 3 plus root 2. If we multiply them, what we'll get? 3 square minus root 2 whole square becomes 9 minus 2 is equals to 7. This example also satisfy this. If the product of two irrational number is rational, then each one is called the rationalizing factor of the other. So 3 plus root 2 and 3 minus root 2 both are the irrational number, and their product becomes here rational. So it means they are rationalizing factor of each other. Similarly, 4 upon 3 plus root 2. So what is the rationalizing factor here? 3 plus root 2. So 3 plus root 2, rationalizing factor of 3 plus root 2 is 3 minus root 2. Just opposite sign with the surds. So multiply numerator and denominator by this 3 minus root 2. This is 4, 3 minus root 2. We are having simple 3 plus root 2, 3 minus root 2. Because of this formula a square minus b square, it becomes 3 square minus root 2. You know that square and root will cancel to each other. So 3 square 9 minus 2, that is 7. So 4 minus 3 root 2 upon 7. This is the answer. Some more examples are here. 10, 5 plus root 3. The rationalizing factor is 5 minus root 3. Multiplying numerator by rationalizing factor. So this is 10, 5 minus root 3. In numerator we are having both the signs plus and minus. So a square minus b square. It becomes 10, 5 minus root 3 upon 25 minus 3. So it becomes 22. So this can be cancelled out by 2. It becomes 5 upon 11, 5 minus root 3. One more example is here that root 3. Now we are having root in both numerator as well as denominator. So rationalizing factor is root 3 plus 2. This is minus sign. So we are having root 3 plus 2. So multiplying in numerator and denominator. In numerator, it becomes the whole square of plus sign. Denominator as it is. Always in denominator there is a square minus b square. So in last year, 9th class, 8th class, you just read about the formula a plus b whole square. A square plus b square plus 2ab upon 3 minus 2. So root 3 cancel out the root, cancel by square. So this is 3, 2. This root 2 and root 2 can be multiplied. 2 root 6. This becomes 5 plus 2 root 6 upon 1. So this is the answer. So one more example. find the value of AB if 5 plus root 6 upon 5 minus root 6 is equals to A plus root 6. So first we will solve the left hand side. Similarly, by rationalizing factor is 5 plus root 6. So multiply numerator and denominator. In numerator there is again a formula of A plus B whole square. In denominator A square minus B square. 5, this is 5, it becomes 25. 5a square plus b square plus 2ab. So this becomes 5. 5 square becomes 25 and this root 6 becomes 6. 2 5s are 10, it is 6. And it is 25 and 6 becomes 31. So 31 plus 10 root 6 upon this is 25 minus 6, that is 19. A plus b root 6. So it is 31 plus upon 19 plus 10 upon 19 root 6 is equals to A plus b root 6. If we comparing both the sides, A is compared to rational number is compared to rational number and irrational number is compared to irrational number. So A is 31 upon 19 and B is equals to, because root 6 will cancel out when we compare, so B is equals to 10 upon 19. So this is the example like this. Similarly, we are having so many examples just like that. If x is equals to root 2 plus 1, then find 1 upon x, x plus 1 upon x, x minus 1 upon x, x square plus 1 upon x. So you have to learn here the formula you have read in your 8th class. So this is 1 upon x. So 1 upon x is 1 upon root 2 plus 1. So 1 upon root 2 plus 1. The rationalizing factor is root 2 minus 1. So multiplying numerator and denominator by root 2 minus 1. Root 2 minus 1 upon a plus b and a minus b. Root 2 square minus 1 square. So you are getting here root 2 minus 1 upon 2 minus 1. So root 2 minus 1 is the answer. Now we are having x plus 1 upon x. What is our x? Root 2 plus 1. What we have found here, 1 upon x. This is under root 2 minus 1. So 1 cancel out. 2 root 2 is the answer. Similarly, x minus 1 upon x. This is x minus sign. This is 1 upon x. When we open the bracket, the sign will change. So this time root 2 will cancel out and 1 becomes 2. Similarly, x plus 1 upon x whole square. So it is x square a square plus b square plus 2ab. We have to find x plus 1 upon x. So squaring, we are finding the square here, a plus b whole square. A square plus b square plus 2ab. So a is x square, b is 1 upon x square plus 2 into x will cancel out. So this formula becomes like this, x square plus 1 upon x square plus 2. So x plus 1 upon x. We have found here, this is 2 root 2. So we will replace x plus 1 upon x by 2 root 2 whole square. This 2 will transpose to left side and x square plus 1 upon x square. This is we have to find. Now here, this is 2 root 2 whole square. This we will write 2 times minus 2 x square plus 1 upon x square. This 2 becomes 4 and root 2 to 2 to the 4 to the 8 minus 2, that is 6. So all are related to each other. Similarly, we are having x is equals to 7 minus 4 root 3. Then find the value of root x plus 1 upon root x and root x minus 1 upon root x. So here is 1 upon x we will find. 1 upon 7 minus 4 root 3. Rationalizing factor is 7 plus 4 root 3. So 1 upon x is 1 upon 7 minus 4 root 3. We will multiply here. 7 plus 4 root 3 denominator 7 square minus 4 root 3. 1 upon x 7 plus 4 root 3, 7 square 49. This becomes 16. 4 4 are 16, 3 is 48. So the 7 plus 4 root 3 upon 1. 1 upon x is equals to 7 plus 4 root 3. Now we have to find root x plus 1 upon root x. So by squaring both the sides, we are having x plus 1 upon x. So root x plus 1 upon x, putting the values of x and 1 upon x and solving, taking the root, we are getting here under root x plus 1 upon under root x is equals to 4. So these are the examples and now the chapter is over. Thank you so much.